some of our perspectives, some of our learnings the last few months to a year about capacity management, especially on Kubernetes. Kubernetes capacity management is a challenging topic by itself, and we know this by experience, either by us trying to optimize our own capacity or infrastructure, or working with our users and customers on that. Today's webinar is just the first webinar in a series of webinars talking about capacity management. Today, we're just gonna lay the ground on defining what is capacity management, the general framework that we use, and then from that point, we're gonna dig deeper into the specifics of capacity management in Kubernetes, like setting the limits and requests and how those impact the performance, and of course, impact your the cost of running your cloud infrastructure. So let me get started here by sharing my screen and walking you through a few slides that would help us to visualize the whole space and what we're talking about here. And of course, if you have any questions, please send them over the chat. We're happy to answer those questions towards the end. And I'll do my best to leave as much time as possible to answer all the questions. And of course, the conversation does not stop with the end of the webinar. We're happy to receive your questions and answer them after the webinar. So just quickly about me, I'm the founder and the CEO of Magalix. I worked at Microsoft Azure. I shipped a couple of products. Also, I worked at AWS and specifically EC2. And I worked at Climate Corp after that, which is an interesting startup in digital agriculture. And I got my PhD in distributed systems, specifically performance engineering. So I've been in performance engineering and optimization for more than 15 years. And cloud actually gave me a golden opportunity to add even more interesting dimensions to that problem. So before we get started and talk about the specifics of capacity management, let me just start with a story. And that story is part of our founding story that will put everything in the right perspective. And that story basically started the first day, me joining Climate Corp. I joined as a director of engineering for the cloud infrastructure. And my manager asked me two questions in the first day. And he told me I needed to answer these two questions for me as soon as possible. What is our ROI? Are we really efficient? Are we really moving fast? What is our productivity? And just 48 hours after giving me those two questions, I came and answered them, no and no, we're not efficient, we're not really moving fast enough. So we launched a project, a 6-month project to optimize and improve our processes and of course save some money. We saved actually more than $4 million at the end of that project. And we were celebrating and ready to take our bonuses. And then 4 weeks after that, we regressed back. And then we just scratch our heads, what is happening? What is going on? And we realized that we were having a major release and our developers, were just basically going back to the old practices of over-provisioning. And that caused us to go back to the old spending habits and old habits of, over-provisioning. So we optimize again. This time it took us only 3 months, luckily. And then also we regress back again. And 1 year into the job, we realized that we're going through that cycle. Failure, success, success, and so on. And it just repeats itself. And frankly, I was sitting in one offsite with my team and we were asking ourselves, are we just a bunch of idiots here, or there's something that needs to be fixed in the technology, in the process? There's something bad here. So I decided to go and talk to the community. And I talked to people from different companies here in Seattle and the Bay Area. And I realized, after talking to such, array of companies, seasoned engineers, they've been working on the cloud for a while. And by the way, at that time, Climate was running on the cloud for almost 10 years, since the inception of the cloud. They all have the same problem. And the same problem just repeats itself over and over and over again. And this is our founding story. And this is what we're trying to do. We said, okay, let's just try to challenge the status quo and figure out a solution that will help engineers to run efficient from day one and keep running efficient without overloading them. So today we're going to just go through those 4 major items. We're going to talk about why it's an important function. It impacts a lot of things, starting from the customers all the way to the team dynamics. What is capacity management in general? And this is very important to know what we're talking about. And I'm gonna walk you through quickly the 5 steps framework that we usually use to optimize capacity for different customers running Kubernetes, or even without running Kubernetes, but that's optimized for cloud native. And then the common mistakes that you should avoid in general while managing your capacity or going through your journey in capacity management. So capacity management, as I mentioned, touches a lot of things. And the question that anyone can have in mind, okay, what's the worst case scenario? What is going to happen if I have a poor capacity management? Is it just only overpaying? Well, actually, surprisingly, it's way more than that. It's not just a bill that stings you at the end of the month. There's way more than that in poor capacity management. So poor capacity management can lead to 3 main areas that are being impacted. And of course, it can go even beyond that, but I'm just highlighting the core stuff. In user experience, of course, if you're not on top of your capacity management, you're going to have a degraded or unpredictable performance, and of course, user experience at the end. DevOps or infrastructure engineers and software engineers always care about that. They want to make sure that they're providing the best user experience for the software that they're building, or for the users through the software that they're building. The second area is team productivity. And I experienced this myself. As I said, we're asking ourselves, are we just a bunch of idiots? What's wrong? And of course, this is just a question that's the tip of the iceberg. We were having lots of contentions. We were having lots of back and forth, trying to figure out a way to make it work automatically without us doing manual optimizations. That causes us to be distracted, can cause also toxic cultures, and that impacts everyone: DevOps, software engineers, engineering leadership, and even it was going beyond that. It was going even to finance, asking us, why you guys are you going beyond your budget? And of course, if you're a small startup or a project that is just getting started on the cloud, your leadership start asking, what is the viability of the business? I'm having a poor ROI. I'm now running the same project with 2x or 3x the budget, or the budget is really not predictable. I cannot do this. And engineering leadership definitely gets pressured as a result of that. So poor capacity management can impact a lot of things if you are not really on top of it, and if you do not have a clear framework in mind to manage it or understand what is that. So, okay, this is definitely, it's good to know the impact of that. And I'm quite sure that some of you probably experience some of that pain. But the question is, what is exactly capacity management? And when I ask that question, I get a lot of answers that sometimes contradicting within the single meeting. But after so many meetings and talking with people, we wanted to simplify that and just try to figure out an easy way to say, okay, capacity management is exactly those 3. And basically, capacity management is the science, and I would say sometimes it's the art. You need to balance the 3 main factors. Number 1 is, of course, is the performance. You want to make sure that your application is performant. What is the single KPI that you would like to focus on? You would like to make sure that you have a great user experience and you meet your SLO or service level objective requirements. And then the second dimension that you need to balance balance your activities and your capacity with is resources types and utilization. And that's by itself is really interesting. And the diversity and the types of VMs and the types of services that now we see in the cloud, even across different cloud providers, even, with the cloud providers that are just getting started or not really as advanced as AWS, they have a lot of VM types, a lot of, possible optimization that you can have there. And then the last part is, of course, the cost efficiency. And this is, the part that most people focus on, and they think, okay, capacity management is all about money saving. And in reality, it's not. Money saving is a byproduct of a few things that you need to do. If you're doing them right, you're going to eventually save a lot of money. But do not think of it as just money saving. It has a lot of other elements. And today we're going to set the ground for that. Okay, let me take you through a real life example to really explain what are those three elements and how you can manage them together. Let's just talk about a multi-tiered containerized web application running on top of Kubernetes and AWS and see two examples. One is not really optimized and another one that is optimized, and how does it look like? So let's assume that I have an app that consists of a web application running on top of Nginx, Redis for caching, Kafka for queuing, and I'm having an array of databases that I use for different reasons. They're all running on top of Kubernetes, each one running its own pod and controller, of course. And now I would like to run this on AWS. This is a real example. The team decided at that time to run it on a cluster that consists of 20 VMs, M6G, 2x large instances at AWS EC2, as I mentioned. And now the team, after doing that deployment, they wanted to take a look at those three factors. And let's just take a look. Those are measured factors. When they observed their CPU and memory utilization, they realized that they're using 10% of their CPU, 40% of their memory. They're meeting their SLA. Their SLA is 1 second or less for 95 percentile of their API calls. And the yearly estimated cost without storage, without considering storage, just compute, is $55,000. Now, you would ask yourself, well, this is really well balanced. Can I get better here or not? And how? Well, if with a very simple analysis, we can easily say, yes, they're meeting their performance, but they're not cost efficient. They definitely can reduce that number. Again, without even considering reserved instances or spot instances, but just by changing the instance type, and we're going to get to that. They definitely can reduce this. And they can improve their utilization. It's not a good thing to go to your management and tell them, we're going to pay $50,000. And by the way, we're only utilizing 10% or 40% of our resources. The natural question that they would have then is, okay, well, can you basically reduce the number of VMs, increase the utilization, and save us some money? Well, the answer, of course, is not always that simple. You have spikes, you have different types of applications, and so on. So in an example like that, I would typically think, with that same team, we're thinking, okay, let's try to characterize, your workloads, and let's try to really reshuffle things around. And with this, using the 5-step framework that we're going to just go through, with this, actually, the team was able to create 4 node pools, and they were able to distribute different parts of the application on those node pools. And as a result, they actually had different numbers. And the numbers are as follows. CPU utilization went up to 50%. Memory slightly increased to 50%. They're still meeting their SLA. Yeah, maybe there is a bit of a degradation here, but 60 milliseconds on average. But they saved 28% of their yearly bill on that small cluster. And if you think of it, now they're a bit more balanced. The resource utilization is higher. They selected the right type of VMs. They're now more cost efficient. And of course, the performance is still good. They still meet their SLA. And we did not make a major change other than just shuffling a few things around. But of course, there is science behind it. There are a few steps that you need to follow to really be able to make that decision in a confident way. And even you can save more by just converting those instances to be reserved or spot, depending on your plans and how your application works. But this is just by shuffling things around. We're not changing anything in the billing model. Okay, so this is just to give you an idea between how just reshuffling things and creating that nice balance between those 3 factors can make a significant change to you. And capacity management or poor capacity management can come in different ways or different kind of shapes. You can have a really nice resource utilization, great performance, but your cost is really bad. You're paying too much. Sorry. You can basically have a very good performance, but very bad resource utilization and paying too much, as we've seen in that example. Worse, you can have all of them. You can pay too much, the wrong type of nodes, and of course you have a bad performance. And of course, one other combination, which is, yeah, maybe you can have a very good resource utilization. You're really efficient, but you know what? You screwed your user experience. Users are not really having reliable services and performance services from you anymore. And we usually see people oscillating between the first one and the last one significantly. They, when they just become in a, or run in a reactive mode, they get the cloud bill at the end of the month. Yes, we have a decent resource utilization performance, but they want to save money really quickly. So they make changes in an unplanned way. And as a result, the performance gets really impacted. And they go into that down spiral of, or the rabbit hole of the capacity management. Cool. So let's quickly jump into capacity management, the 5 steps capacity management framework. And this framework has a lot of details in it. I'm just walking you through the high level stuff today, and happy to answer your questions. And as I mentioned, we're going to go through a lot of the details and subsequent webinars. So basically, it goes as follows. You usually start by correlating different matrix together. And then the main idea is correlating the performance with the resources, and then set the right dashboards as a result, adjust the resources values, which is in technical terms, in Kubernetes terms, the requests and limits of CPU and memory. And then you adjust the allocatable capacity. This is when you start selecting your VM pools and sizing them. And then the last step is optimizing your build. And once you have the initial setup done, you need to repeat step 3 through step 5 with a reasonable frequency. It depends on the team goals and their ability to really go through these frequently enough. So let's dig it through each one of them. So step number 1. To give you an example, or use the example that we demonstrated at the beginning, you need, first of all, to select a single KPI. And the KPI usually is connected to your user. If you have a web application and you care about, let's say, the latency a lot, plus, of course, the throughput, but for simplicity, we're just going to talk about latency here. You need to set a goal. So let's say I would like to set 1 second response time for 95 percentile of my API calls. Once you have this goal, you want to connect this to the internal latencies and connect it also to the remaining, the other internal kind of KPIs, like, for example, the database query time or cache lookup key lookup latency, and so on. But at the end of the day, you would like to tie these to memory and CPU. Your main goal is, if I add CPU, the question is, if I add CPU or memory or improve the IO, if any of those services, what's the impact of that on my KPI? So for example, if I go and give Redis cluster or containers more CPU, and maybe of course with a certain percentage, and more memory, what is the impact of that on my end latency or my user experience, or SLO? Once you figure out that, that's a really important step for you. So that, because at the end of the day, this will tell you how much you need to allocate to each pod. And of course, you're gonna aggregate that to the cluster and nodes level. So this is for step number 1. And step number 2, of course, you're able to basically draw the relationships between different matrix. You need to set those in dashboards. And usually on an ideal dashboard, it would have the SLA of your microservice. And then it would, the next level is the resources that you allocated to that microservice. And of course, where those resources are coming from. So this is basically what you need to do. And this is just a visualization for that. Pod resources, an aggregate of those resources allocation across the whole cluster, and then how much of those resources that I allocated are actually consuming from my cluster. And then the last point is, do I have any hotspots or cold spots in my cluster? Do I have some of my VMs that are really overutilized, or some of my VMs are really underutilized? What if I change my VM from, let's say, M family to R family or C family for some of the workloads? Would that make a difference or not? Those workloads, those dashboards will help you to run through those if-else scenarios. This is just an example graph. So for example here, and this is from our dashboards from Magalix console. Here you can see that for a single pod, you can see the amount of memory that is used, how much is being allocated, and what is the limit on that. And of course, because we provide recommendations, there are 2 additional lines around the recommendations. This is another chart, really interesting one, as we call this a sunburst chart. It's an interactive chart that shows you the breakdown of memory usage at the cluster level, and takes you all the way to a single container. So how much overall memory is being consumed, and then you can break it down or go down all the way to a single container, so that in an interactive way, you can know where your resources are going to. It's just in line of step number 2 of building and having the right dashboards. Of course, Grafana can help you with that, but you need to do a lot of internal setup. And we still use Grafana internally for some pieces that we think that Grafana will help us with. But just have that right mental model in mind about how you should build your dashboards. And then in step number 3, and this is the interesting one, and this is where you get a lot of possibilities, and this is where it gets a little bit technical. And also at that step, you want to start engaging your developers, because this is where at the container and pod level, you start now thinking of how much resources each one of those need. There are 3 main categories of scenarios. There's cost saving, when you just reduce the limits and requests when they are too high. There's the second category, which is basically impacting the system and app stability. If you're missing CPU or memory requests or limits, this is definitely going to impact your infrastructure or your cluster stability significantly. And of course, the app performance in general, and there are 2 categories of that. There's a CPU starvation, and there's a high CPU utilization, and they're different. And I'm gonna actually dig into the CPU starvation. But as a bonus, actually after the webinar, we're gonna send you a series of information or details about each one of those scenarios, explaining to you what is that scenario, what exactly it talks about. And of course, we're gonna dig into those even much deeper in a future webinar. So let me talk a bit about CPU starvation, because this is the least popular, I would say. No one really dug deep into that this scenario, and it's the most impactful on your application performance. So CPU starvation basically is when your pod is throttled, just in very simple terms. And this is due to the differences of this is actually the differences in units, time units between Kubernetes and the Linux scheduler. So when Kubernetes actually, when you set the limit to, let's say, 1 core, basically your or half a core, your application is expected to consume that core in a uniform way throughout 1 second. But in reality, the application can use all the half core in less than a second, and in that case, the cluster will throttle it. At the right here is a clear example. This is an application. This application actually is running on top of Kubernetes, and it requires around 200 milli cores to run. And then in the second scenario, the second graph, this is how the pod is being scheduled after setting the core limits to 0.4. This basically means that it's going to get 0.4 of a core every 100 milliseconds. And in that case, as you see in that chart, is going to run and then stop, run and then and of course is going to get descheduled and so on. This results, as you also see on the timeline here, that your application taking almost double the time to run. This is definitely a very bad user experience. This is going to impact your application performance significantly. A lot of engineers really ignore the throttling matrix. So we recommend that you take a look at the NR periods and throttled and throttling time, and you can calculate the throttling percentage out of these. And also, interestingly, in Linux kernel version 4.18, they fixed that issue in a way that if there are no competing processes within that time here, your process, even if you set the limit, your process will get the right CPU share without being throttled. So make sure that you at least take a look at these. This is just a quick hints about the CPU starvation. It has a lot of details in it that can impact the performance of your application. Just a very simple setting of a CPU limit value can impact your application performance a lot inside Kubernetes. This is just an example from our dashboard handling specifically the starvation scenario. What we do in a nutshell, we basically give you, when we scan your containers resources or pods resources usage, we also look for the throttling matrix. And as a result of that, actually, we give you a recommendation to change the limits or change the request so that you avoid the throttling. The example that we have here is for one of our time series databases. And this database actually has been having a really low request and limit, specifically limit. And as a result of that, it was throttled most of the time. And we were recommending here to basically set the limit from 6 cores to 12 cores. And actually we did, and the throttling got really to zero. And our database did not have that intermittent timeouts that we were having. So this is just, in a nutshell, one of the features that we offer here. Very important tip, and this is something that we experienced ourselves and we experienced with our users. A lot of the time, engineers get really overwhelmed with the amount of possible improvements that they can get. Our recommendation is tackle the top 20%. Most of the time, the top 20% are going to save you a lot. And then over time, tackle the remaining ones. I'll give you an example. This is also a feature that we just recently released. We realized that we are giving our users 150, in a decent cluster, 150 possible optimizations every day. But you know what? Not all of these are really as important as, let's say, the top 20. So the top 25 recommendations in that particular case is saving the user around 20%. The user can just, with one click, apply those recommendations or those kind of optimizations, and just literally in 20 minutes, they save themselves 80 gigabytes without doing any further kind of analysis and going back and forth and so on. So number one, prioritize. That's very important, because otherwise you're going to get into resources adjustment fatigue. You can really get easily overwhelmed, either you as an infrastructure engineer or your software developers. Then the second one is the right frequency. We were also discussing this internally here. What is the right frequency? Should we do it once a day, twice a day, every week, and so on? This is something, it depends from one team to another. But for example, in our console, we provide this on a daily basis. And the reason is because on daily basis, you can have enough information to tell you, or enough data to tell you whether your application is trending up, trending down, and whether you need proactively to start working on adjusting the resources or not. You can make it more frequently, but the problem with resources adjustments that you need to restart your pods. And with that restart, that definitely destabilizes your cluster. So there's some sort of a balance that need to be done here. That's why I mentioned at the beginning, sometimes it's an art, right? It's something that you want to have some sort of your own heuristics around and optimize for. And the last one, of course, is it's a team sport. The infrastructure team can take ownership, but if you have hundreds or thousands of containers or pods and workloads, it's really hard and tough for a few engineers to manage that. You want to make it part of what the rest of the team does, and assign those resources to your team, or give your team a few keys to the kingdom so that they're able to adjust their resources and run efficient. And this is also part of what we offer here. And at Magalix, you can add your team members and you can give them access to change some of their pods resources through our console. We give them the recommendation and then we provide the automation after they approve them. All right, the last piece, or the step number 4, is adjusting your capacity or node pools. That actually requires a very simple step in high level. You need to characterize your workloads. You basically want to know which of my workloads are memory intensive, which are CPU intensive, and IO, of course. And based on that, you select, once you do that categorization, you need to create node pools and allocate, or basically use the labels and selectors to provide hints to Kubernetes scheduler to push the right pods to the right nodes. So in the example that I provided at the beginning, basically we categorized some of the workloads. Some of them are memory intensive, and that's why we like Redis, and we allocated it to our nodes, our 5 nodes. The reason for that is not only because it gets more memory. We can get the same amount of memory with M machines, but the price of a single gigabyte, single memory gigabyte, is much cheaper on our instances compared to M instances. And by the way, it's much more performant as well. If you dig deeper and understand the kind of hardware that AWS runs our instances on, they have more advantages in terms of the bus and the size of the cache and so on, to optimize for memory, for memory intensive operations compared to M6 instances, for example. So you need to do that. This is very important. Just that simple categorization will help you a lot. How this can be done, there's a lot of research online. We're happy also to provide some pointers, but it's relatively simple. It's not really that hard. It gets tricky when your workloads actually get some variance. Let's say with some APIs, it's memory intensive. With some others, they're CPU intensive. Then finding the that balance, or finding that right categorization might get a bit tricky. Cool. This is again an example of something that we provide. We know that this is really tough. It's an optimization problem, which is finding the right number of pools and allocating your pods on those pools, or to those node pools. This is an example of a relatively small cluster on Azure, and we were basically recommending here. So basically, the admin was running the cluster on 3 DS2 instances on Azure, and that basically had this amount of capacity: 5.8 usable cores and roughly 16 gigabytes. The CPU utilization was 15%, and memory utilization was 5%. And this is the hourly cost based on different plans. But we were suggesting to the user here that he need to, based on the workloads that we have, that he need to create 3 different node pools and start allocating pods to those pools. And as a result of that, his CPU and memory utilization will get higher. And of course, at the end of the year, he would be saving, just using the on-demand, $3,500 roughly. And actually, if you take a look at those charts here, it tells you that this is how much they're using, this is how much they're allocating or requesting, and this is how much is available actually right now. And this is basically, this huge gap tells you that there's a lot of unoptimized infrastructure, a lot of or capacity, a lot of capacity that just you're paying for and you're not really utilizing. This is for CPU and this is for memory, and they've been running inefficient for almost a month in that particular case. All right, the last step, and frankly, it's the easiest step in all of these, which is just selecting your billing model or optimizing your billing model. You now know how much resources you need, you know how many instances you need and their types. Now it's just the easy accounting stuff, which is, do I need to keep them on demand, keep them reserved, or convert them to reserved or spot instances? And it depends on your plans. The most common mistake that a lot of teams start with that, or they say, you know what, let me just go to AWS and buy reserved instances. And that actually increases the tension even more in teams, because yep, they go through the step, they feel this saving, they see the 30% saving in their bill, but you know what, they're going to add more workloads, they're going to make changes to their application, they're going to come back to their managers and say, we need more. And then when they take a look at their numbers, they're just poor, poorly allocated or poorly utilized. And in that case, of course, it just comes back, it bites you back because you did not do the right optimizations from the beginning. This is just a byproduct. This is the very last step that you should do. So this is basically, everything about the 5 steps. Let me just walk you through the common mistakes, and then we'll end at that point and open up for Q&A. The most common mistake, number one mistake, we see in teams using huge generic virtual machines. M6 or M type is the most used family inside AWS, and it's the most underutilized type of VMs inside AWS. I saw this when I was working there. Fire and forget, many people think that, well, I need to do it only once every 6 months or every 3 months. It's not like that. And a lot of teams do it in a reactive way. And I understand that a lot of teams, why they hate that process, because it's really painful. It's really hard to get everything lined together. And this is part of what we're trying to do here at Magalix. We're trying to make it really easy so that with a couple of clicks, you get the recommendation and you just apply them really quickly. It can be done by a single role or for team only. I saw that also in big and small companies. As of course should not be the case. Your development team should manage that also with you. They should know how much resources they need for their workloads and pods. They should be really good citizens. Becoming too efficient, and we saw that, and we actually made that mistake ourselves. We basically wanted to do optimization every hour. This is too much. This is basically was impacting the stability of our cluster just to save a few dollars. There's a line that you should stop at, or there's a level that you should stop at. You cannot really be that efficient. Is gonna just there's a diminishing return on investment after that point. Optimizing your bill only, as I mentioned, is also another mistake. Ignoring the system overheads is also another thing. You may say, you know what, okay, I'm gonna get, let's say, a total of 100 cores and maybe 500 gigabytes of memory for my system, and then you ignore how much the Linux and the other overhead processes are gonna consume out of all of these. So it's important to consider the allocatable capacity and just deduct those overheads, and it's really important. And important to have also a visual of that, because it's going to tell you whether there's something fishy or something bad happening within your system processes. And of course, missing the big picture and not doing that budgeting exercise. one thing that we did at a certain point that was really useful for us, we just got a very simple Excel sheet. We listed all the workloads, and we listed basically how much on average they're using in terms of CPU, memory, and of course the max and median and so on. And then we listed how much of requests and limits we set for each one. And we just did the simple math. And we, just summed all of these, and we took a look at that, and we realized that the math actually, the math does not add up in terms of how much we need and how much we have. You can just do that simple exercise, and feel free to reach out to me after this webinar. I can send you that, but this is a very, very basic way to do it. There are definitely other more advanced ways, but if you just want to get started with the basics, you can do that. Sometimes just doing that exercise, getting your team for 15 minutes, 20 minutes to list all the resources that they use and do that simple budgeting exercise would help a lot. All right, cool. So that's mainly it. Just in a nutshell, as I said, capacity management touches user experience. It impacts your team productivity. It impacts your infrastructure ROI and business viability in general. So that's why it's a really critical function. It's a team sport that everyone needs to be engaged, with. And it's about balancing three main factors: performance, resources utilization, types and utilization, and of course, the cost efficiency. These three things, you need to balance them together. And again, sometimes it depends on your application. Maybe performance is really important. I don't care about the money. Well, that's fine. It's a choice, but you want to make sure that you're making a conscious decision about that. And of course, we went through the 5 steps framework, starting from connecting the matrix together, building your dashboards, and then going through the three next steps by adjusting your limits, and of course, creating the node pools and optimizing your bill, and going through that. It's all about building the right habits and building the right culture with the right tools inside your organization. This is key to your peace of mind as an engineer, and to your team success and business, of course, success and growth in general, especially in these tough days where you need to do more with less. Capacity management becoming at the forefront of a lot of companies and teams, and that's why we thought of sharing some of these with the community. All right, cool. So at the end of it, I would like to offer the webinar attendees a free consultation meeting for 20, 30 minutes. I can go through your what you have right now, and if there's anything that we can recommend you to fix, we'll definitely share this with you. And then that meeting, no obligation, just book that meeting. I'm happy to just listen to your problems, and see if I or one of my team members can help you out with this. This is the URL here. We can also share it in an email, follow-up email after the webinar. All right, that would be all. Happy to get your questions.
Cool. So thanks, Mohamed. That was super in-depth. Thanks for walking us through that. We have 2 questions from the audience so far. We'll start with Neil. So I'm going to click the answer live button, and what I'll do here is I will give Neil, if you're in the audience, you are still in the audience, I'll give you talking permission if you're still here. And if you are, go ahead and ask your question live to Mohamed. We'll wait a few seconds. If not, I'm happy to just ask it.
Yeah, my question was just the format of the metrics that you guys are sending stuff in.
Can you elaborate more on that, Anil?
Like, are you using your own custom metrics like New Relic does or Datadog does, or are you using some open standard? Like, how is the metrics format done?
Right now, we use actually our own, but we're gradually moving into the standard Prometheus matrix. Right now, it's just our own simple JSON-based format.
Okay, thanks.
Cool.
Cool, thanks, Neil.
Well, I'm interested in, Neil, are you using right now Grafana or a specific dashboarding tool that's why you're asking that question?
I mean, there's definitely Grafana is what we lean towards for the most part. So you can use different format, obviously metrics in Grafana, but we prefer Prometheus.
Got it. Got it. One quick thing worth mentioning here. There is a beta feature that that we can share with you if you're interested. That actually allows you to export some of the data in different formats, and a subset of our matrix actually is included. So happy to take this offline and discuss it in more details.
Does your agent, sorry, a follow-up question to that, does your agent have a prom exporter?
No, not at this moment.
Okay, thanks.
Cool. And we have another question from Amr Imam in the audience. So I'll do the same thing. I'll go ahead and allow you to talk and you can ask your question. And if we don't hear from you, I'm happy to just ask it to Mohamed and Mohamed can answer it.
Hi, Mohamed. Thanks for the great demonstration. I have a question. How can I get a better sense of CPU to memory ratio? Because, you know, I scale my cluster workload based on the CPU, but I always have memory waste. How can I resolve this?
So there are different ways to do that. You can basically select, the simplest way is to select a unit for your CPU and memory. So for example, select, say my unit is 1 core and for CPU and for memory 1 gigabyte. And try to measure the ratio between the core and the memory. So get the pod and see, does this pod use, for example, for each core, it uses 2 gigabytes or 4 gigabytes. So if, for example, you have the simple case of one CPU, the pod uses 1 CPU, and as a result, it uses 4 gigabytes of memory, this is definitely a memory intensive app. And in that case, we would recommend this app to be running on our instances on AWS or memory optimized instances, because in that case, the cost for each gigabyte that you get is going to be cheaper. And also, you're not going to get into the situation of underutilizing your memory. And of course, it goes the other way around, which is, you know, for each core, let's say you use only 500 megabytes of memory. So in that case, you're definitely CPU intensive. And in that case, you want to move that, that container to C instances. In your particular case, it looks to me that it needs to run on a C instance type, a CPU optimized instance type on AWS. And of course, I'm just using AWS as an example. Azure, Google, DigitalOcean, IBM, all the other cloud providers, they have also the same VM families. Hopefully that answers your question, Amr.
So based on my workload, you can recommend me the right node to choose from?
Yes, that's what our node advisor does right now. It basically tells you the different node types that you need to use, and the missing piece yet that we're working on is how to basically map exactly which nodes, which pods need to run in which nodes.
All right, that's great. Thanks.
Yep, welcome on.
Cool. So I did put out the word to anyone else who's still here. We still have time for Q&A. If there are any other questions, please chime in either in the chat or raise your hand and I will give you talking privileges. Otherwise, if that's the last question, I'll kick it over to Mohamed one more time to wrap up for us, and we'll end it there.
All right, sounds good. Cool. Well, if there's no other questions, as I said, we will share with you guys after the webinar some other insights. This webinar is just the first in the series about capacity management. Capacity management is a broad topic, has a lot of it, and the reason it's complex, you have an underlying infrastructure that has lots and lots of possible variables that you need to play with. And of course, you have the complexity of your application or your system in general and your business needs. So connecting those together and making sure that they run in harmony is definitely a challenging task. It's a very important thing that you need to make sure that they're running properly together. So I look forward to seeing the rest of you in the next upcoming webinars. Other than that, as they said, good meetings end early, so we get 8 minutes back, I guess.
Nice. Well, thanks a lot for coming today. And as Mohamed said, there'll be a follow-up email with a link to this recording. You'll also get a link. You'll like I said, you'll get a copy of our capacity management ebook, and we'll also send a follow-up for any of you who want personal hands-on consultations for Mohamed and us to walk you through that. Scheduling is at your leisure. No obligations. So thanks again. Thanks for coming. We definitely appreciate your time, and thanks from all of us at Magalix. Have a good rest of your day.
Thank you. Thank you, guys. Take care. Bye.